Oh, yes, Christelle, you can take it away.
Okay. Hello, everyone, and thank you for joining today. Um, there are two ideas on which I'm working at the moment, and today I'm going to present one of them. And if I get the chance later, I can also present the second one. What I'm presenting today, the title is Intergenerational Analysis using Census Data, Correction of Bias Due to Missing Offspring. And as motivation to this work, there are evidences that intergenerational educational persistence affect the effectiveness of education expansion in reducing inequality of educational opportunities. So it's important to include intergenerational analysis when we are analyzing a particular education policy, because the differential education decision made by different type of household before education policy affect how education policy decrease or not inequality. But the problem is that the existence of this kind of data that will allow this type of analysis is rare in developing countries. Like it's not like it is the case in developed countries where households are tracked over time and we can observe all the children in a particular household over time. But data from census are common and available over a regular time period in developing countries. And so if we can find a way of using census data to do intergenerational analysis, that will be a good way of dealing with this missing data problem. And the good thing is that census data happen to provide information on every member of a given household for all the household that is surveyed and their relationship with the head of the household. So we can use that type of information to link individual to at least one of their parents. For example, if a person identifies as being the child of a head of household, then we can create a link, a parent-child link between that person and the head of the household. And this will allow us to have a sample of people with information on at least one of their parents. But the problem with this approach is that we only get this information on children living in the same household as one of their parents at the time of the census. And so if we want to keep the advantage of having this information, we are losing part of the data which constitute of individual not living with their parents. But those individuals happen to be different from the one living with their parents in terms of financial stability or employment status. And so that creates a selection problem. And also another factor is that people not living with their parents are more likely to be married. And so those are factors that are actually correlated with education attainment. And so not considering those individuals can be problematic if we are doing intergenerational analysis using census data. So before I get into what I really want to do in this paper, before getting into that, I want to talk a little bit about the particular context, like data context in which I want to do like empirical test for the method that I'm developing in this paper. And that context is the context of Benin and a particular policy that I'm considering, which is the free elementary education for girls in rural areas. That was in 2003. And so I did like some work before where I investigate the differential effect of that policy for different type of household. And the way I actually get the information on parents was exactly using what I described. And so the problem is there. So what I'm trying to do now is to still use the differences method that I used before to investigate the treatment effect for different type of household. But now the objective here will be to develop a methodology for correcting for the missing offspring bias, like the children or the offspring that are not living in the same household as their parent, and so I cannot link them with their parental characteristics. And in other words, more specifically, I will try to get identification, either point or partial identification of the treatment effect for each type of parent, considering everybody in a cohort this time, not just people for whom I have information on parental characteristics. So in order to do that, then I need to identify those individuals in questions, like people not living with their parent. And one way to track them is by considering people who identify as something else than children of a head of household, like people who identify as head of household themselves, or spouse of a head of household, or siblings or grandchild, or nephew or nieces of a head of household. So those are like people not living in the original household, like not living in the household of their parents. And so, yeah, I can link them to the parental characteristic, but I still observe them in the data. I have information on the individual characteristic, and so that can be used to get better treatment effect, differential treatment effect. Now, this particular policy and particular context that I'm considering, which is the free elementary education in rural Benin, has the challenge that since the policy was in rural Benin, then I'm considering parents with girls in rural Benin. And in the previous paper that I worked on, I find out that household with boys in rural areas were better controlled for household with daughters. And so the analysis was like mostly focused on rural areas. And so that's create a challenge in this new method that I'm working on, because then I have the problem of tracking people who migrate from rural to urban areas. And so the one way to overcome that challenge is to use information on migration of individuals. And one good thing about the census data is that it provides information on the current location of individual and the location of birth. But the not so good thing is that in the particular context of Benin, it provides those information at commune level, and areas are classified as rural or urban at arrondissement level, which is a smaller subdivision. So using commune information will not allow me to get a perfect match of who moved from rural to urban areas. One way that I find to deal with that problem is using the following procedure. So we have some communes that are 100% urban, like Paku, Cotonou, and Port Novo. And in addition to those communes, we have 6 other communes that are highly urban, which have at least 70% of the population classified as living in urban areas. So those 9 communes alone represent about almost 50% of the urban population over the 77 communes that we have. So that kind of tells how representative of the urban population they are, because people living in other communes are more likely to be in areas classified as rural, even though in those other communes we still have some smaller portion classified as urban. So if I use that definition for rural, urban, and so on, I can get migration from rural to urban by considering whether a person was not born in any of those 9 communes, but is now living in one of them. So that will tell me that at some point, this person migrates to those communes. And this one implicit assumption here is that people's education decision is made in the commune where they are born, like they go to school in the commune where they are born, which is basically true if we consider primary education that I'm considering in this work. So using that definition, I have this migration flow that give at aggregate level a sense of migration from rural to urban. And as we can see, there is like less migration from urban to rural, but from rural to urban, we have like about 20% of people living in one of those 9 communes that were actually born in some other communes that is not. that is not one of them. So using this definition now, I get like 3 groups that I can classify in 2 bigger groups. The 3 groups are the offspring who identify as being the child of a head of household. Those are people that I can link to to one of the parent and then get parental characteristic for them. The second group is people who are identified as something else, like one of those things that I cited before, but they are still living in rural areas. So I keep them as they are. The last group is the group of people who identify as something else, were born not in one of those 9 communes, but are now living in one of them. So those are people whose parents are probably in rural areas, but who migrate to the city. So using that, the last 2 groups are now groups of offspring that I do not observe, offspring that I cannot link to any parental characteristic. And the first group is the one for whom I have some parental characteristics. So yes.
Your previous slide, is that the title, no, the previous, where you just came from? Oh, look, okay, no, move forward.
This one?
Okay, no, go ahead. Maybe it was on my side. I realized that it was like the title was cut, okay, it's okay. Go ahead.
Okay. So using this definition to cut those people into 2 groups, I now try to give evidence of what I was saying, that those people, the one living with one of their parents and the one who moved out, or the one living with at some other places, are different. And I show this for multiple variables. The first graph is for education, education as binary variable in this case. And the first graph is for before treatment cohort. So in the work that I did before treatment cohort for the particular policy that I consider would be people between 19 and 28 years old in 2013. And those are basically people whose education decision was made before the policy, so they were not affected. They were less likely to be affected by the policy. And the after treatment cohort are people between 13 and 18 years old. And those are people in the right age range to be affected by the policy. So using these two, I try to compare the average of the proportion of educated people for people living with one of their parents and people living somewhere else. And we can see for male, we don't have much difference between those 2 people. But for female, we have a gap in favor of those living with their parent. And my explanation for this is that female who moved out, as I will show later, are more likely to be married. And so they don't go to school and then parent marry them at early age, then that's why they are not living with their parent anymore, which is not the case for those who are still going to school and still living with their parents. So that will explain why, like if you are enrolled in school and you're still going to school, you're more likely to be living with your parent at the time of the census than if you're living somewhere else and get married. Another thing that is different for these 2 groups is the type of work that they have, a kind of work that will not only offer a job stability, but also high income, which is permanent job workers. And we can see that the proportion of permanent job workers is higher among people who are not living with their parents. And that's explained by what I was saying before, that moving out decision is affected by the type of job that you have, if you can sustain yourself and if you can get a household by yourself. Those kind of things influence your decision to move out of family house. The last thing is the marital status that I also mentioned before. So the same thing here. So this is like some sort of evidence that we have this difference between the 2 groups. And the most, even though the other one are also correlated with education attainment, the most obvious one is the education attainment itself, which is different, especially for women, for those that we are observing and those that, for those that we are observing in a household with their parents, and we can link them, we can get some parental characteristics, and those that are living somewhere else. So if we consider only those in living with their parent in the analysis, clearly the result will be biased because we have some selection problem. So That's what I will consider this in a more formal model in the next slide. So,
Hey, Christelle, please, could you go back to your previous slide?
yes.
Yes, what is the age range here?
Sorry, can
Age
you say?
range.
So for the first one, for the before treatment people, the age range is between 19 and 28 years old. And for the after treatment is between 13 and 18 years old.
Okay, go ahead, please.
Okay. So before I get into the identifying the bias from using only offspring that I'm observing in a household with parents, I want to just quickly talk about the original framework that I'm considering to estimate the treatment effect, which is a difference in differences method. I use more specifically a non-linear difference in difference because the outcome variable was binary and I did not want to assume linear probability model, but that's like a different, like it's a different story. Here, I'm more focusing on the identification. So today, for what I'm presenting today, but basically the treatment effect, the heterogeneous treatment effect on the treated for individual with characteristic S is just like the difference between the expected outcome, the conditional expected potential outcome with treatment and the conditional expected potential outcome without treatment. And those two are given by the following expression based on the nonlinear difference in differences approach that I use. But it doesn't necessarily need to be these two expressions. It can be just a linear form. It can be estimated non-parametrically or anything. So it's not really important that I'm using a probit regression here. But basically, equation one is what I'm trying to identify. Yeah. So the problem with this equation one and with the identification of the treatment effect on the treated from equation one is that X is a vector of X1 and X2, X1 being individual characteristics and X2 is the household characteristic. And the vector S2 is missing for offspring who moved out, offspring that I'm not observing in a household with one of their parents. And so like more formally estimating tau without them will be biased because they're different individuals. So here I'm trying to estimate with them, like with including them. And for that, the first step for doing that is by considering this moving out decision model. So I kind of presented a bunch of observed characteristics that will affect moving out decision. And so here in this equation here, Mij is basically the moving out indicator for individual I in age range A and group G. So this will be one if this whole expression here is larger than a certain threshold, like usual selection model. So and still following usual selection model, I can just assume that B is 0. And assuming a distribution for mu here, I can get the probability that somebody moved out of family house that I will use later on in my analysis. So from this probability is clearly identified and can be estimated from a probit logic or whatever estimation strategy. So then using that, I start with the expected potential outcome without treatment, but everything that I'm about to present also hold for the potential outcome with treatment. So using the law of iterated expectation, I can decompose this expression right here into this one. So the first part is basically the same expression, the same expectation for the subgroup of unobserved offspring. So from now on, I'll be referring to people that are not in the household of their parent as unobserved offspring, and the one that are in the household with one of their parent as observed offspring. So the first expression is for the unobserved offspring, and this happened with this probability here. And then the second one is for observed offspring. So the expression B here is clearly identify because S2 is observed for those people, for the observed offspring. The problem is with A, the expression in A, which is not identified for the same reason like S2 is not observed for the unobserved offspring. But it's only this shorter regression that is identified, the one without X2. So one assumption that I made to get moving for now that I will relax later on is this point identification assumption, which is basically saying that the omitted variable bias in using this short regression instead of using the long regression is the same for the observed and the unobserved offspring. And by using that assumption and defining this bias, because I can define this bias for the unobserved offspring and for the observed offspring. And for the observed offspring, I denote that by B1. And it's just the difference between the estimation using the long regression and the estimation using the short regression. And same thing for the unobserved offspring. And if I equate these two bias, then I can identify the long regression, this expression here, the long regression for the unobserved offspring. So yeah, that's basically what I did. And then I can just replace this back into the original expression and get the identification for the expected potential outcome without treatment. And same procedure will give me expected potential outcome with treatment as well. And then I'm done basically. Now, the problem with this approach is that the problem with this assumption is that I'm kind of like, this assumption is kind of implying that conditional on the individual characteristics, the household characteristics affect the observed siblings and the unobserved siblings offspring education attainment the same way. But I just show evidence that they have different education attainment on average or at aggregate level. So that's kind of basically saying that they might have also been affected by household characteristics or parental characteristics in different way, which is possible. Maybe this can not be the case in some contexts, but in some other contexts, it can definitely be the case that siblings are affected differently by household characteristics, and those who moved out are just affected differently. And so this assumption can be easily challenged. That's why in the next step, I'm trying to relax that. But by doing it, I will lose point identification. And so I have to rely on partial identification for the treatment effect. Do you have any questions before I move? Okay. So I analyze now I analyze the problem in a more general setting of a short versus long regression framework. So my Y variable is the education attainment variable. The X, yes.
No, just a technical suggestion. Can you just maintain the full screen presentation instead of scrolling the pages?
Yeah, I don't know how to do that. Wait.
Oh, okay.
Let me
Otherwise,
try.
like sometimes when you just scroll the page, we don't
Yeah.
have the title is cut, and then we only see the
I have full screen, but I had full screen, but then it
what are you are
came
using
like
Foxit?
this.
You are using Foxit, right? Okay, if you do
Okay,
that.
this is good now. This is good now.
Okay. Yeah,
Yeah.
it's good now. Yeah, you can keep on doing that. Yeah, thank you.
So I have no, it's not good.
It's good only when you click on it.
No, it wasn't the full page.
Do you have Adobe Reader instead of
No.
Foxit? No.
No, I don't.
Okay. Then you can move on. But next time, if you want to present it in your department, I'll suggest you to use Adobe Reader, which will not create this problem. Thank you.
Thank you. Okay, so this X vector is this composite of X1 and X2, and I observed two independent sample from two different populations, one from the observed siblings offspring population and another one from the unobserved offspring population. For the observed offspring population, the probability of Y giving X1 is known. Probability of X2 giving X1 is not known because X2 is not known. And also probability of Y giving X1 and X2 is not known. So that kind of make it complicated to directly apply the short versus long regression literature to this setting, because in that other setting, P of X1 giving S2 is supposed to be known, and then these two can be used to find some informative bound on P of Y giving X1 and S2, because the joint is not known, but the marginals are known. But in my case here, only one marginal is known, and the joint is not known, and the second marginal is also not known. So it makes it a little bit complicated to apply directly the existing framework. But the other thing that I have that was not in the existing literature is that the joint here, P of Y giving X1 and S2 is known for the observed siblings. So I have two possibilities here. Since I'm interested in estimating this long regression for this sample right here, I have two possibilities. First, either I make some distributional, like dependence between the two distribution of X1 giving S2 for the observed and unobserved siblings, and just directly like use this dependence, like correlation in distribution sense for the two distribution and get some bounds for the unobserved offspring. Or I rather did that for this joint distribution because I know this for the observed offspring. So at this point, actually that's where I'm at, because I'm not sure what kind of distributional assumption I can make, and it will not be like too far from the data and too far from reality as well. So I guess that's all I have. And if you have questions, suggestions, please give them. Thank you.
Okay, Christelle, thank you. Just quick summary of what you're doing here. You want to, I would not suppose, I will ask you to, if you can, in really short sentence, to summarize what is exactly the research question and what trying to do. I know you said, but just can you just summarize it like quick, like?
Yeah, sure. So I have two samples. Sample of okay. Let me start from the question that, or from what I want to do is that I want to be able to do intergenerational analysis with census data. Now, the way I'm getting information on parents is problematic because there are offspring that are missing because they
Intergenerational analysis you want to do here is about education.
Yeah.
Okay.
So the fact that some offspring are missing is problematic because those offspring happen to be different in terms of observable and probably also in terms of unobservable. So that creates a selection problem. Now I'm trying to still use that data and do what I want to do by including those individuals who moved out in the analysis. And to do that, I will need to somehow find information on their parental characteristic in order to keep keep the possibility of having the treatment effect for parents of a specific characteristic, like educated parent versus non-educated parent kind of thing. And in order to do that kind of analysis, I need information on the parents. So for offspring that are living with their parent, I have that kind of information. I'm trying to use that to get treatment effect this differential treatment effect for the offspring who move out for whom I'm not observing parental characteristic. So like in 2 sentences, that will be what I'm doing.
Okay, okay, then, all right. So the terms are, I think is a kind of a release, is a specific literature, at least to me. I don't know about others. So if anybody has anything to say, the floor is open to you guys. But what I understand here now is when you say intergenerational analysis, you're interested in one generation, like from parent to kids, right?
Yes.
But your problem is that you miss part of the kids because some of them moved out.
Yes.
So this created bias. So you're trying to now kind of use some approximations to go around that problem.
Mhm.
Okay, if anybody is familiar with the literature, please, you guys, feel free to jump in.
I wish I were micro person, but I'm not. I'm sorry.
What did you say?
I wish I were a micro person.
Oh, you're a macro guy. Here you are.
I actually really need like suggestion on how I can like make assumption about two distribution kind of thing. Like, because that's where I'm stuck at this point. Making assumption between two distribution, like some kind of dependence kind of looking assumption. Right.
Yeah, but this, okay, Christelle, but the specific assumption that you need here, right?
Mhm.
That's where I feel like a little bit helpless. Because like there are tons of assumptions that you can make about, if you take two distributions, like, um, uh, I don't know, you are saying correlational assumption thing, but I'm not really used to.
Yeah, I thought about making assumption like some sort of stochastic dominance assumption, but then the problem is that is probably not the case because it's true on the at the aggregate level. I show that those who moved out are like this compared to those, but it's probably not uniform. So if I make some sort of stochastic dominance assumption, I'm kind of assuming that it's uniform, which is probably not the case. So I need something less strong than.
What I understood from your first slide is that those who moved out are different from those who are inside, right? Not, they
Yeah.
are not the same, even at the aggregate level. Or
Yeah,
are
at
they the same?
aggregate level. Yeah, at aggregate level, they are different.
They
But
are different.
yeah, but like at individual level, I can't say that for this, if I take one particular individual who is in a household and one that is outside, then I should have this kind of relation that this one should be more educated on this kind of thing. That's not true. So at aggregate level, they are more educated for women, but at individual level is not the case. Some people moved out and are more educated, for example, than some
Yeah.
other people who are living with their parents.
Okay. Now or maybe what I'm going to say does not make any sense. I know that the census, because you are working on Benin, right? So I know that the census that we have, the SGPH, does not keep track of one household. Like, it is not that when you take this census, you have the same ID for the household, then you can track that household to the next census, right? It is, they use different identification. That's make a huge problem. Even myself, I'm in that problem. Otherwise, I'm thinking, can that solve, if it was the case, let's say that you find a data set that can keep track of the same household over time, like kind of you have a time series on the household. Can that, do you think that can solve your any of your problem? Then if
Yeah,
it is the
that's,
case, then
sorry, finish.
if it is the case, then instead of focusing on Benin and if you don't find a solution to make the appropriate assumption to move on, then I would suggest you apply your same framework, your same theory, estimations method to another country that keep track of their household, where you can have a clear time series, the US being one, or I mean, the developed country. They used to keep track of household that way. Do you think it can go help you go around it? No.
Yeah, so actually that is the problem, right? That is one of my motivation points, that this tracking system that they have in developed countries, we don't in developing countries. So the work is actually for developing countries being able to still find a way around not having that tracking system and still use the regular sample census data and do what we want to do. So using some developed countries' data to go around will defy the purpose of the work, because then in the end, I'm still not solving the problem for the developing countries because we don't have that tracking system.
Okay, so but what about you use the developing country, right? What about you identify a developing country like in Africa, right? And a developed country, right? Which are alike, at least in terms of education. Like if you take a country like Rwanda or Tanzania, Rwanda specifically, the education rates, education is even better than some developed country. I cannot mention by a name. I don't have it in my brain right now, but I think I watched something, a documentary, that there are some countries like Botswana, Rwanda in Africa that are classified as developing country, but they have education that you can literally compare to any developed country. So if what is missing for you in estimating the thing on the developing country, it is that you cannot really make assumption and move on. Sometimes you cannot make assumption. You just think, you just use your brain, turn it around. You cannot just make it. Even if you make it, will not mean any sense, right? So so I convinced that maybe it will be that you do some comparative analysis between the two countries, and then you estimate the missing parameter from the developed country, and then you fill in the gap in the developing country, like from the developed country, and then fill the gap in the developing country, or something like that. This kind of technique.
Yeah.
Like when we are estimating different, all the other non-experimental method that we use, we judge the parameters based on RCT, which is kind of the golden environment for a causal inference analysis. So most of the performance that we do is that we use the RCT, and then we say, okay, if we are in a setting of non-experiment environment, and that then the parameter is supposed to, if everything is well identified, then the parameters are supposed to behave that way, and we compare to the RCT. And there is even a paper that comes out by Oster, Emily, and Christelle made a paper, and then Oster, Emily from Broad University extended the paper on that. So I mean, the same kind of technique, but now use different geographical. So maybe if you think about that sense, it can help you one way or the other. I don't know.
Okay. Yeah. Yeah, I will try that. Thank you very much.
Okay. If nobody else has questions, then I think we can just call it a day. And feel free to reach out to Christelle, and whenever you come across, because sometimes you have the presentation, everything is new to you, but later, as now we are aware of that work, when you come across a paper, and you can send the way of Christelle, and that helped me a lot. I remember I presented something in my dev lab, in my department here, and later a lady sent me a paper, and now that paper is so convincing that I'm changing my whole theory to fit in that paper. So thank you, Christelle, for letting us know your work. And I guess everybody will send your way anything that is come across, and you can also reach out to people individually so that people can
Yeah,
send
thank you
anything.
everyone for coming.
Yeah, yeah. Thank you, Christelle, and good luck on your presentation.
Thank
In
you.
your department. Okay, bye bye.
Bye everyone.
Bye bye.